Memory depends on spacing effect and variation. Memory has puzzled scholars since the dawn of civilization. Find out how new research shows that spacing out study periods, along with varying the context of the item we're trying to remember, improves our memories. My dad had a joke. As we get older, we lose two things. The first thing is our memory, and I forget what the other thing is. He was a singer, and he'd use that joke if he forgot some song lyrics. I'm getting to the age where I find myself resorting to that line as well from time to time. We all have a memory, but humanity has always had trouble understanding and explaining how our memories work. Plato thought memories resided in our immortal soul. As usual, Aristotle was more practical, thinking that memory had something to do with the way our senses interact. Hermann Ebbinghaus was one of the first scientists to use scientific experiments to study how memory works. More modern scientists like Richard Atkinson and Richard Shifrin showed that we have more than one kind of memory. They came up with a model based on sensory, short-term, and long-term memory, and later scientists have expanded on how we encode, store, and retrieve our memories. Meanwhile, neuroscientists have used brain imaging and related techniques to observe how our brain's neurosystems form and retrieve memories in brain regions like the hippocampus and the prefrontal cortex. Today's scientists study memory using an interdisciplinary approach, with input from psychologists, neuroscientists, computer scientists, sociologists, and others. For the past 12 years, Dr. Emily Cowan has been studying sleep's role in how we manage our memories. She's currently a postdoctoral research fellow at Temple University, working in the Adaptive Memory Lab. Professor Cowan is the lead author of a study, The Proceedings of the National Academy of Sciences, published this week. The researchers discovered that the best way to memorize things varies, depending on what we're trying to remember. When I think back to my university days, I can remember cramming all weekend for an exam. I passed that test, but in the long run, I really didn't retain anything I learned from that process. The research suggests my experience is not unique. Scientists have known for quite some time that it's better to space out study sessions if we're serious about learning and retaining knowledge for the future. This is called the spacing effect, but there's an important issue with it. The studies on which it's based assumed that we're always trying to learn the same kind of thing in the same circumstances. In the real world, our experiences change all the time. Even things we do every day, like going for lunch, have variables, like who's working behind the lunch counter today or who the other customers are. The scientists wanted to find out more about how these kinds of variables affect the spacing effect. So they conducted 2 experiments in which they asked participants to study combinations of items and scenes. Some of the pairings remained the same on each repetition. Other times, the item would stay the same, but the surroundings would change. In one experiment, the researchers asked the participants to learn the pairings and then test their recall using their cell phones. That way, the researchers could ask them to learn pairs at various times throughout the day and night. In the other experiment, the scientists collected the results from the participants in one simple session. The idea was to compare the effects of memorizing throughout the day along with the type of content participants memorized. With this, we were able to ask how memory is impacted both by what is being learned, whether that is an exact repetition or instead contains variations or changes, as well as when it is learned over repeated study opportunities, Professor Cowan explained. The experiments confirmed that the spacing effect works. It's better to space out learning than to try to pull it together all at once. Even so, there's more to the story. When the researchers varied the scenes, that improved participants' memories. So memorizing subjects in different contexts or different aspects of a subject make it easier to remember. Also, spacing worked better when items and scenes were repeated instead of varied. Spacing only benefited memory for the pairs that were repeated exactly, and only if there were pretty long gaps, hours to days, between study opportunities, explains study co-author Dr. Benjamin Rotman of the University of Pittsburgh's Casual Learning and Decision-Making Lab. For example, if you're trying to remember the new person's name and something about them, like their favorite food, it is more helpful to repeat that same exact name-food pairing multiple times with spacing between each. Bertrand Russell famously wrote that the good life is one inspired by love and guided by knowledge. He also pointed out that we could have no knowledge without memory. So understanding how our memories work and how to make sure we remember and retain things accurately is vital to our knowledge. If knowledge guides the good life, the more we learn about memory, the better our lives can be in the future. Professor Cowan concluded by saying, "Our work suggests that both variability and spacing may present methods to improve our memory for isolated features and associative information, respectively, raising important applications for future research, education, and our everyday lives. We always have more to learn if we dare to know."